Hello all, this is Neil from Eduaker and welcome to this interesting session on Raspberry Pi camera. Now, Raspberry Pi has become the heart of the Internet of Things domain, and camera is one of the most interesting modules that you can add on to this interesting hardware as well. Now, let's begin by exploring the Pi camera for that matter. Now, the Pi camera was one of the best additions to the Raspberry Pi component because this module has helped the users to use the perspective of camera into one of the smallest and the most effective component of the Internet of Things. Now, the main objective of the Pi camera module is to help you capture images, capture videos, time lapses, even slow motions as well. Now, apart from this, the Pi camera also helps you capture videos in full HD at 30 frames, HD at 60 frames, and even VJ videos at 90 frames as well. Now, there are two versions of Pi camera that are out there. Now, the latest version being the camera module version 2, which was introduced in 2016. Now, although there's not much of a difference between both these cameras, there has been a slight increase in the resolution, wherein you had 5 megapixels for the first module, you have 8 right now. And even the sensor on board has been swapped out, wherein there was OmniVision for the first version. Now it has been replaced by a Sony sensor as well. Now, talking about the Pi camera, you need to be quite careful while you're working out with the Pi camera. So let me help you understand how you can set up Pi camera with your Raspberry Pi as well. Now, there are 5 different stages on setting up Pi camera. We'll be looking at each one of them one by one. First, let me help you understand how to connect your Pi camera to the Raspberry Pi. Now, this is very important because we've used 3 camera modules and we've managed to burn out 2 of them. So please be careful because this is a very delicate ribbon and this is also a very delicate module as such. So let me help you understand how you can attach the CSI cable to the Raspberry Pi, and then I'll also help you understand, once you've done this, how to enable the camera as part of your Raspberry Pi as well. So this is my Raspberry Pi camera and this is the version 2 of the camera. Now if you notice, this is the camera that you can see, and this is something that's really delicate, so please be careful. Now one thing that I really want you to notice here is the connector here. So this is called the sunny side up and this is called the silver end. Now you need to be really careful when you're plugging this in. So let me just bring in my Raspberry Pi here as well. So here we have our Raspberry Pi 3 and I'll just show you how to connect this. There are mainly 2 precautions that you really need to consider while you're working with the Raspberry Pi camera. One thing is just please ensure that the Raspberry Pi is switched off or disconnected before you connect the Raspberry Pi camera as well. Now this actually leads to a high chance of blowing up your camera. We've already successfully managed to do that once. So please ensure firstly that the Raspberry Pi is switched off and also that the connection is correct. Now if you notice the silver side present here, this should be facing the HDMI port that is present here. Now in order to connect this, let me just slightly push it off, and this slot needs to be slightly raised up. You insert it like this. Okay, please be very careful. Once you've successfully inserted it, then just push down the hinge as well. This will lock it in. So make sure the silver side is towards the HDMI and the sunny side is to your 3.5 mm jack side as well. Now it's recommended that you get a case wherein you can also support the camera because it's slightly challenging because the ribbon in itself is delicate. So when you get a case which has the camera support, it will be really useful to you as well. So it is a very delicate item, so please be careful while you're working with the Raspberry Pi camera module. Moving on, let's look at how to go into the interface and enable the Raspberry Pi camera module for your Raspberry Pi as well. So now that we've successfully connected to our Raspberry Pi, let me show you how to connect or enable the Raspberry Pi camera on your Raspberry Pi as well. Now what I have done is that I have established a remote connection between my Raspberry Pi and my system using VNC viewer as well. So this makes it quite easy for me to show you what I'm doing on my Raspberry Pi. So once you have successfully connected and turned on your Raspberry Pi, you can go into the menu and then go to the preference section. Here go into the Raspberry Pi configuration, and what you need to do is go into the interface section here. Once you're here, make sure that you have enabled the camera option as well. By default, this would be disabled. Now I have enabled most of these for different purposes, so you can just enable the camera option as well. Once you're done with this, then we'll go on to the next stage, which is understanding how you can capture images from the Raspberry Pi camera and how to capture video from Raspberry Pi camera as well. Now, Raspberry still is actually a shell command which lets you access the camera module and capture an image. Now, the command for capturing an image is Raspberry still -o and name of the image that you want to store it as. Now, -o is basically to open the camera and capture the image, And at the same time, if you want to rotate the image vertically or horizontally, you just need to pass the parameter -vf or -hf. Now both of this will either flip it vertically or flip it horizontally, and when you pass both of them, it'll completely flip it around as well. Now, apart from this, if you wish to capture a video from the Raspberry Pi, you can use the command raspi-vid. Doing this will help you again capture the video from the camera module. Now, this is something that gets stored by default as a H264 video as well. Now, if you wish to convert this, you can use the following command, which is sudo apt get install -y gpack. Now, this video will actually help you install MP4 box onto your machine and help you convert your H264 videos into MP4 format as well. Now, once you have it in MP4 format, then it's quite easy to play this video and check it out as well. Now, again, if you want to run it for a fixed duration, then what you can do is that you can also pass the duration as part of the parameters while you're specifying raspi-vid as well. Now, one thing that you need to keep in mind while you're doing this is that the time frame that you're passing here is in milliseconds. So please be careful while you're doing this. Now, although I'm specifying 10,000, it's only for 10 seconds that the video is going to be captured as well. Now, let me help you understand how you can do all this by using a Python function rather than a shell command as well. For that, what you need to do is that you need to install a package called PyCamera. Once you've done this, then you can easily access or you can easily perform all the operations as part of your Python program using the PyCam module as well. Now, what you need to do is that first you need to update all the packages that you want. Then you need to install the Python PyCamera package that's present. Now, if you have two versions of Python on your machine, then I would recommend that you run both these commands, that is Python-PyCamera and Python 3-PyCamera. This in turn will ensure that you have the 2.7 version as well as the 3.x version of PyCamera present on your machine as well. You can also install PyCamera using pip install as well. So the command is sudo pip install PyCamera as such. Moving on, let's talk about how you can actually create a program or how you can use a Python program to record the videos for the same 10 seconds. Now, earlier what I had done is that I had just mentioned that run for 10 seconds using the shell command raspi-vid. But technically speaking, this does not really account for all the challenges that may come across while you're actually capturing a camera. Now, that is where you use a Python program to help you ensure that even if an exception is come across, then you can handle it. And to do that, we'll be actually using the with statement here. Firstly, what I would like to do, I would like to import the time package here. Now, importing the time package also helps me access to the PyCamera module, and the PyCamera function will in itself connect to the PyCamera module and the data that comes with it. Now, when I'm using with function here, this in turn will actually help me in handling all the exceptions and encapsulating the proper task and cleaning up the tasks as well. So it basically becomes a best practice while you're using the PyCamera or while writing any codes for that matter. So most of us programmers would like to consider all the scenarios and take care of it. And in this case, Python has given us the with statement to take care of it as well. Now, if I use the command camera.startPreview, what is going to happen is that it's going to give me a preview of what my camera is seeing. And I call a sleep for 10 seconds. This in turn will ensure that for the next 10 seconds, the camera preview is on. Once that's done, I'm going to stop the preview. So what I have here is a preview of what my camera is seeing for 10 seconds as well. But this is not where it restricts. There are various other commands that my PyCamera brings in as well. Talking about these commands, when I use the command camera.capture, it captures an image, and camera.startRecording and stop recording will in turn help me capture a video as well. Now, if I go back to my previous program here I can also write camera.capture in order to capture the image between that 10 seconds. Or what I can also do is that I can also start recording at the same time as well. So I start a recording, let it wait for 10 seconds, and then I stop the recording as well. So these are different commands that you usually use together. Apart from this, if you want to capture a stream, then you can use camera.capture my streams followed by what type of stream that you want to store it as well. Now, if you wish to stream the video that is coming from your Raspberry Pi, then you can use the command camera.capture followed by my stream and the type of stream that you wish to store. Now, again, this also can be recorded wherein you use camera.startRecord, it captures the stream, and you specify the quantization that is needed to this as well. Now, again, if you wish to play with some of these properties of the camera as well, you can play around with the brightness, you can change the resolution, and you can even add a weight with respect to it. Similarly, as you have a timer function in your standard cameras, the same can be used here as well. So let's say I want to start the recording after 5 seconds, I can do that as well. Now with this, let's come to the demo of this session. Now, this is a slightly interesting demo, and I'm quite sure most of you are looking forward to this as well, wherein we'll try to help you understand how you can actually set up a security camera at your home as well. Now, talking about the overall system here, now here what I would like to do is that I would like to capture the image of anyone who comes to my door. Once that's done, I would check if this person is a recognized person or is it someone that already has access to the house. If not, I can always prompt my user and then give access to it. If not, I can deny access to it. Now, to those of you who've actually seen our IoT projects video, you would have noticed that in Mark Zuckerberg's section, he had actually allowed his parents. Now, I do not want to manually have to do this, wherein I'll just automatically allow people to do this as well. That's a smart system, or that's an enhanced system that we really would love to achieve as well. So we would not be completely able to achieve it, but we will take our tiny steps towards it, and we can all enhance it as per our requirements as well. So firstly, what we're going to do is that we're going to detect the face, we're going to gather this data, we're going to compare it, and then we're going to start recognizing data as well. Now, again, this is a learning process that takes place. This is something that involves a lot of understanding, and this slightly gets interesting for most of you as well. Now, when we talk about face detection, now the first stage of face detection is wherein a program actually decides whether an image has a face or it does not. And this stage in itself is called a classifier as well. Now, in order to achieve this, OpenCV actually provides us with two pre-trained and ready to use face detection classifiers which are part of it. We have the HAR classifier and we have the LBP classifier as well. Now, one thing that you need to notice, or one thing that you need to keep in mind while you're working with this, is that the classifiers themselves process the image while they are in grayscale as well, because it gives the machine quite clarity on whether to classify it or not as such. Now, when I talk about each of the classifiers, whether I talk about the HAR classifier or the LBP classifier, each has its pros and cons. So let's actually try to understand this. Now, the concept of face detection is not something that's quite alien to most of you. And I'm quite sure you've all seen it, be it in our Facebook application, Snapchat. Some of us have also seen it on the ATM machines as well, wherein face detection is incorporated. And if you wish the most simplest methodology, or if you want to see the most common example that's out there for face detection or face recognition, you can see it in most of the phones today as well. Now, again, here what happens is that the two algorithms that are most widely used are the HAR classifier and the LBP classifier as well. Now, again, both of these classifiers are mostly processing the images in grayscale because we don't actually need the color related information to decide if there is a face or not. Now, again, there are going to be two classifications present here. The computer program which actually decides whether there is a positive aspect wherein the face is present or the negative aspect where the face is not present also. So this is how you decide, or this is what you call a classifier for that matter. Now, in OpenCV, as we have seen, there are two different classifiers, which is the HAR classifier and the LBP classifier as well. Now, again, when you talk about the HAR classifier, it is actually a machine learning approach that we take. Again, this was created by Paul Weiler and Michael Jones, wherein they had trained many positive images and negative images without faces as well. Now, this in turn actually started helping them understand that extracting feature takes quite some time. And if you consider both segments, when you consider HAR and LBP, HAR actually takes up a slightly more time, but at the same time, it gives you a slightly more precise solution as well. Now, what it actually does, it actually considers the adjacent pixels to the region where the face is detected, and then it actually sums up the intensity of these pixels in each of these regions as well. Once it's done, it actually calculates the difference between these sums, and then it uses them to differentiate between this section and the subsection of the images as well. Now, when it comes to the LBP section of this, here it creates a 3x3 window at the time of image as well. Then what happens is that it starts comparing from the center pixel with all the other pixels which are greater or equal to the value which you set as 1 or 0 as well. Then again, it goes on to read the binary value in a counterclockwise order and converts it to decimal, which are center values of the pixel as well. Now, what happens is that this process is completely repeated one after the other, and you have an easier or a smarter solution to this as well. Now, again, as we have discussed, both of them have an advantage and a disadvantage as well. Talking about the HAR classifier, it has a very high accuracy when it comes to detection of face, and there's quite minimalistic false positive. But the challenge is that the computational time that it takes is quite slow, and again, the training time that it takes is quite long as well. And even in dark segments, it's not quite accurate as well because it requires high clarity with respect to the images or the scanning area that it takes into picture. But at the same time, when you look at LBP classifier, its computation and training time is actually quite fast and shorter when you compare to the HAR classifier as well. Now, it is quite robust when to any illumination changes. That is, when there's a change in lighting, it's still comfortable and capable of handling this. But at the same time, it's not quite accurate, or it's not on the same level. At the same time, has a high chance of false positivity as well. Now, before we move on for ahead, let me just show you about these packages slightly better. Now, if you come into your OpenCV package, now I would recommend that you download the OpenCV library from GitHub itself. And if you come inside the segment and you go inside data, what you can see here are the different HAR classifiers and LBP classifiers. Now, if you go inside the HAR cascade section, here you can find different XML files present here, which will help you understand or help you recognize different aspects of a body. It can start from eye, it can start go to eyeglasses, and then so forward as well. Now, what we'll mainly be using is that we'll be using the frontal face segment here. Okay, and again, these are XML files, so even if you open them and if you see them, you would not perfectly get a clear-cut idea. But this is something that we have to use as part of our program as well. Meanwhile, while this is opening, let me go back. Let me show you the LPP segment as well. Okay, now what you see here are different values that are associated. Again, these are different values to help you identify or help you understand how the face recognition should take place as such. Okay, now again, it's a very huge document. So what they're trying to do is that they're again going to try to restructure it again. I think you've got a simple idea at this point. So let me just close this and let me go back. Now, if you check the LBP cascade segment as well, here you have different segments. So again, what we'll be using is that we'll be using the frontal face segment as such. So what I've done is that I've just created a separate folder where I've kept my program and these two OpenCV files for different algorithms as well. Now, coming back, we've done with our detecting the face. Let's talk about recognizing our faces as well. Now, till here, what I've done is that I have detected my face, but I need to start recognizing this face as well. So face recognition mainly can be classified into three different steps. First step actually dealing with the data gathering stage. Now, in this stage, what you're mostly going to do is that you're going to gather any relevant information with respect to that face. So usually this is done when you have multiple photos of a person, and then you start identifying or you start training your machine on this face, and then it starts recognizing this face every time that it comes up with an image of the same as well. Now, there are three different functions that OpenCV provides us to do this, and let me give you a brief idea on each of them so that you know which to use where. Now, first comes the Eugene faces. Now, Eugene faces actually takes all the images at once, looks for all the important and useful components in these faces, which are known as principal features, and then passes it on. Now, one key factor that makes, or one key challenge with respect to the Eugene face function is that it requires a good amount of illumination. But at the same time, when you have your Fisher face, here individually images or individually features are extracted rather than extracting one by one, and this in turn actually does not have a challenge with the illumination segment as such. Third is your LBPH, which is your low binary pattern histogram, and this is very similar to your LBP as well. But what happens here is that you create a binary matrix and convert into decimal factor, and then you actually plot a histogram with respect to it. So what happens here is actually a comparison with respect to the histograms that are present. So each face will have a correspondingly different histogram, and I just compare these histograms to in order to identify which face it is belonging to. Now let me come back to my Raspberry Pi, and before I go forward, as we said, this segment actually deals with two parts. First is actually capturing the detection, and the second is with the recognition part. So let me first show you how you can detect it. Now, we've already discussed about detection or how to capture any intrusion detection in our Raspberry Pi 3 tutorial, where we actually captured someone opening the door and coming in as well. Once I've captured this image, then I need to start recognizing. Now, firstly, let me show you this program here. If you want more details on how it works out, then you can definitely check out our Raspberry Pi 3 tutorial as well. Now, if I use the following code, let me just expand this a bit so that I think you may not be visible to you. Let me just increase the font size. Yeah, now I think you can all see my code as well. Now, again, we're using different packages here. You're using user libraries, CV2, the time, and NumPy as well. Now, I'm first going to set the first frame, then I'm going to decide whether there's any detection as well. Okay, now for this, as we have mentioned in our Raspberry Pi 3 tutorial, you can use the IP camera application, which is an Android application, and you get an IP address as well, or a URL, which I've specified here. Now let me just run this and show you what I'm seeing at this moment. Now what it's going to do also is that it's going to capture the last image that the camera sees as well. So any change with respect to it, it's going to overwrite until I quit or I exit from the program as such. So let me just run this and just zoom in a bit. So let me go back to my desktop and I'll run the camera application. Now what it's doing is that it's connecting to my phone camera and it's going to create or show you what I'm seeing or what my phone is seeing at the moment. So what you're seeing is my Raspberry Pi setup here. As you can see, it's set up on a curve because it slightly tends to get heated up, but you can see it's a separate device as well. So this is my first frame, and what I'm going to do is that I'm going to put my hand in front of it and I'm going to make this as my last frame as well. While this remains, I'm going to press Q to quit from this, and it also has created an image called test.jpg here as well. Let me just open this, and if you see, it's my hand that has been captured. So what happens here is that it captures the last frame as well. So if you want to get a better understanding of which image it captures, we'll rerun this, but before that let me just remove this file. Okay, so let me just send it to the waste bin, and then what we'll do is we'll just re-execute this program. I'll start by keeping my hand in the front of the camera itself. So this is my first frame. Okay, and any change to this, I'll just move it off completely. So this is going to be my last frame, and I press Q to quit from this, and let's just recheck the image as well. So you can see it has captured the last frame as such with respect to this. So it's a very interesting thing for capturing this. And now let's actually come down to our program which talks about face recognition and face detection as well. So this is the program that will help me detect the face, train my application, and also understand which face belongs to whom as well. So I have imported my OpenCV2 because that is where my face detection and face recognition algorithms are present. I'm going to use the OS module here as well because I need access to the drives or the path where these images are going to be stored as well. And NumPy is one of the very key programs, or is one of the very key modules which is required for any face detection recognition as well, because the information that you're going to be using would be stored as a NumPy array for that matter. Now again, what I'm going to do is that I'm going to actually identify the faces of three people. Okay, I'm going to identify whether the image that I'm passing is of Ronaldo, is of Messi, or is of Robin. Okay, or if it does not fall into either of these three, it's going to give it as null as well. Now first program or the first function that we're going to be working is with respect to detecting the face. Now as I said, all the images are going to be converted into grayscale, so that's what I'm going to be using cv2.cvt color to grayscale conversion. Once this is done, I'm going to create a face cascade for that matter. Now cv2.cascade classifier actually specifies which kind of classifier to be used. Now for this program we're going to be using the LBP classifier. Okay, and as you see, it's for the frontal face as well. We've seen there are different aspects, but we're going to be using LBP frontal face classifier as such. Now this face is going to store the list of all the faces that I'm going to be detecting or I'm going to be identifying. Okay, so for this, what I'm going to do is that I'm going to specify face underscore cascade, and then I'm going to ask it to detect in multi-scale parameter. So I'm going to say it has to identify in grayscale. The scaling factor of the image is set as 1.2, and the minimum number of pixels that it should consider is 5. Okay, now if no faces are detected from the images that I pass, then it has to pass the parameter as none. But if it is detected, then I want all the 4 coordinates with respect to the x and y axis, which I'm going to be storing in x, y, w, and h. Okay, x, y, width, and height with respect to this matter, or I'm going to specify which part of the image does the face actually contain. So I'm going to specify with respect to the 4 coordinates that I'm going to be passing. Once this is done, then I'm going to define the next function, which is to prepare my data. Now, as we've seen, first comes detection, then comes preparing. When it comes to it, I need to specify the path from where it has to pick up the images for that matter. So let me come back. Let me show you where the images are present. Now, when you see inside training data folder, okay, I have actually 3 folders present here, which is my S1, S2, and S3. Now, if I go inside S1, you can see there's Ronaldo's photos. If I go back into S2, you can see there is Messi's photos. And if you see inside S3, there's Robin's photos present here. Now, let me come back to the code. Now here what I'm doing is that I'm passing the path, then I'm calling the face function as well as the labels. Now again, the face is going to hold the subfaces of all the subjects, and labels actually help me identify which it belongs to as well. Now what it's going to do is that it's going to run a for loop wherein it goes through each of the images present in the path. Now again, what we've decided or what we have started with the naming convention is with S123. So what it's going to do is that it's going to check if the folder name starts with S, because usually there are system folders separately. So it is going to check if the folder name starts with S. If it does not, then it's going to go into the next loop. But if it does, it'll check that folder as well. Then what it's going to do is that it's going to create the label for it, or it's going to identify which folder I'm present in. Now, if you actually go back to my training data, you can see I have specified 1, 2, 3 after this. So it's just to help me identify which label it belongs to as well. You can use any different naming conventions that you want as such. Then what I'm going to do is that I'm going to specify where the folder or where the images is present, which is actually one level inside this. So I'm going to go into the next directory, and then what I'm going to do is that I'm going to run a for loop for all the images that are present in this. If an image or a file for that matter starts with dot, because system files usually start with dot, so those are going to be ignored, but others are going to be recognized using my OpenCV, wherein I'm going to read the image first. I'm going to show you a message that says training on the data. I'm going to resize the image to a size that is comfortable for me, which is 400 pixel to 500 pixel. Okay, and then I'm going to wait for 100 milliseconds for that matter. Now, what you can see here is that I'm calling the detect phase function, which is present earlier. So this again is a callback to the previous function, where it goes up and it actually calls the previous function that we have created to detect the phase as well. Once that is done, it's also going to revert with me the position as well as the phase or the ID which it belongs to as well. Now, if a phase is present, then I'm going to append it to my phase list, and I'm also going to add a label to this phase as well. Once this is done, I'm going to destroy these windows, because again OpenCV creates a lot of windows, so I'm going to ensure that it's destroyed by doing it twice as well. This is done. I'm going to return the faces which I have and the labels correspondingly as well. Now what you need to understand is that here the faces here are of different players as well. So each of the faces present in each of these images is going to be segregated. It's going to store this into a location, and it's going to start training on them as well. Then what I'm going to do is that I'm going to prepare the training data. Now this again is something that is becoming a recursive function for that matter. It's going to be calling itself again, where it goes back, it goes to one level up, and it's going to keep calling itself until I have trained on all the folders which are present and all the images present inside that folder as well. So once this is done, what happens is that it prints me that data has been prepared, and then it also tells me the total number of faces and the total number of labels also present here as such. Finally, what I'm going to do is that I'm going to create our LBHB face recognizer. So for this, I'm going to call the LBHB face recognizer function. So if you remember, we had discussed about 3 different face recognition functions. We're going to be using the LBHB face recognizer function here. Once the function has been defined, then I'm going to pass these faces so that my machine can learn and train itself to identify these faces in future. Now, what I'm going to do is that I'm going to just create a rectangle across their faces, so that it becomes a differentiating factor for them, or it helps them separate where the face is with respect to it. And once this is defined, or once I've created a rectangle across their face, again these x, y, h, z are the different coordinates of the face, and I'm just going to draw a rectangle across them. Again, I'm going to specify which color. So this is your RGB value, so it's going to be a green color box that's going to be defined, and I'm also going to print the name of the person present here. So what it's going to do is that it's going to identify which person it belongs to, and it's going to print it in Hensi plain. Okay, and what it's going to do is that it's going to be printed again in green color as well. Now now the most important function comes, which is prediction. Now in prediction, what I'm going to do is that I'm going to pass an image. The image copy is going to be created, because we do not want to manipulate or work on a single copy of an image, because in case of any challenge or any issues, we do not want to overwrite or lose the image for that matter. Once this is done, then what I'm going to do is that I'm going to call the detect face function, which in turn will help me identify who the person is. Then what it's going to do is that it's going to predict the image using our face recognizer, and then it's also going to print the confidence, or how sure it is that this face matches. Now what I want you to understand here is that if my confidence is below 30, that is, if I'm not sure that this person's image is correct or the face is detected, then what happens is, if it is greater than 30, it's going to draw a rectangle, and then it's going to write who the person belongs to, and it's going to return this image for me on the screen as well. Now I have 2 images that I'm going to be passing here. If I just go on to my desktop, let me just show you. First is abc.jpg, and the second is ron.1.jpg as well. So let me just show you the images. So you can see here I have ron.1.jpg, which is an image of Ronaldo, and I'm also going to pass abc.jpg, which is an image of Messi. Okay, so these are the 2 images I want to identify, and I'll be passing this to my program. let me just run this program so that you get a full-fledged understanding of what we have written here and you understand how this works out as well. Okay, so once I've passed this image, then I'm going to call the predict function so that it predicts whose face that this belongs to or whose this face is as well. Once that's done, I'm going to destroy this. Now, I hope you've got a simple understanding of this. If you are interested in the code, please give us your mail ID. We will be happy to share the code with you as well. Now, let me just execute this so that you get a clear-cut understanding of this. Now let me just zoom in so that so you can see it has started picking up the faces for recognition. So you can see it's starting to prepare the data, it's checking out all the images, it's reading the faces, it's trying to detect the faces for itself. Now you can see total faces are 22, wherein it has identified 22 images, and it also has started to predict it, and it's given me the confidence of the face detection that it has taken place as well. Now the prediction has completed. For Ronaldo, it has successfully predicted the face, and it also has put in the text. And if you see for Messi also, it has done the same, but the text is very small here because the image has been resized for that matter. Okay, so it has successfully predicted this, it has detected it, it also has recognized it as well. Now it has also told me who this face belongs to as such for that matter. So this is how our face recognition system works completely. Now this is just one of a very minute or one of the basics examples of this. And if you want to create a complete full-fledged system, let me give you an idea on that same as well. Now, if you wish to have a very great system or something that's really effective out there, something that's not too hard to build, then this is something that you should really consider. Place your camera, which is a wireless camera, on top of your door. Okay, use the Raspberry Pi to detect the motion. What would happen here is that every time there's a detection, Raspberry Pi would detect this happens, and then it would pass on this information onto the cloud. The reason for doing this is that it becomes quite faster and it's way more effective in that matter as well. Here the face would be detected, recognition would happen, all the information regarding these faces would be present on the cloud itself, and once it has identified that this is a valid user, then correspondingly it will allow the door to be opened as well. But what you need to understand here is that this in turn can also be configured for you to have an application or a notification sent on to your mobile application from the cloud as well, because most of the mobile application APIs for pushing information is very easily accessible and configurable on the cloud as such. So with this, we come to a conclusion of this session. I hope you've had a great learning experience. Please feel free to comment any of the queries that you have and hope you have a great week. Thank you and goodbye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!